Can I get a thumbs up at home that you hear me and see the board okay? All right, awesome. Here we go. Guys, we're in the home stretch. We are in fourth marking period. We are going to make it. All right. We left at the end of last week in section 5.2, dividing polynomials. You did not go crazy. I skip all the way to section 5.6 next. I just feel like coming out of the synthetic division that this makes the most sense to do next. And then I'll go back and start doing other sections. But I kind of work my way back down. Like first we'll do section 5, then we'll go to section 3, all right? So just bear with me. But I do feel like this has a nice flow if we go to this section next. Okay, this section is going to be about the remainder theorem and the factor theorem. So if we're going to work with these theorems, you have to remember what it means for remainders and factors. So remember, factors divide evenly into their products, and therefore the remainder will be 0. When something divides evenly in, the remainder is 0. We know that. We learned that in elementary school, okay? So for example, take 5 times 8 equals 40. Since 5 times 8 multiply to 40, they are called factors of 40. They live inside of 40. But factors don't just multiply to 40. Factors should also divide evenly in to their product. So 5 should divide evenly into 40, and it does, because 40 divided by 5 is 8, no remainder. 8 should divide evenly into 40, it's one of its factors, and it does, because 40 divided by 8 is 5, no remainder. So when something is a factor, they're also telling you that if you try to divide it in, it would divide evenly in, because it's a factor, okay? So therefore, 5 and 8 are factors of 40, and they will divide evenly into 40, and the remainder will be 0. Okay, but guys, we're not working with numbers anymore. We're working with polynomials, these mathematical expressions, right? So instead of looking at 5 times 8 equals 40 with numbers, let's look at it with polynomials. So if you take the polynomial x plus 3, and you multiply it with the polynomial x plus 5, right, you FOIL that out, it equals this polynomial. So therefore, since x plus 3 and x plus 5 multiply to x squared plus 8x plus 15, they're factors of it, which means they will divide evenly in. So when I take x squared plus 8x plus 15 and I divide it by x plus 3, guess what? It's going to divide evenly in. It's going to get me x plus 5. It's going to get me the other factor, remainder 0. Because if something is a factor, it's going to divide evenly in. It's going to get a remainder of 0. If I take this polynomial and I divide it by x plus 5, guess what? It's going to divide evenly in. It's going to get me x plus 3. It's going to get me the other factor. Okay? So again, therefore, these two polynomials are factors of this one. They will divide evenly in, and the remainder will be 0. This is what we know about factors and remainders, okay? All right, so in order for some polynomial of the form x plus a or x minus a to be a factor of a given polynomial, they must divide it evenly into it, and therefore the remainder must always equal 0. So at the end of the day, if something's going to be a factor, we're looking for a remainder of 0. Okay, so let's look at example 1. All right, so guys, in example 1, it wants to know, is x minus 1 a factor of that polynomial? Well, guys, this is a yes or no question. Either yes it is or no it's not. In order to find out if this is a factor of that, I have to figure out if it divides evenly in. And what's the one piece of information we need to know if something divided evenly in? The remainder. So all I need to figure out right now to answer this question with a yes or a no is what's the remainder? Did it divide evenly in? So right now, based off what we know, we could long divide this, get the remainder, or we could use synthetic, which is supposed to be faster. So guys, let's do a round of synthetic. We know that last number represents the remainder. As long as that last number is 0, the answer to this question is yes. All right, so here we go. So let's remember how we synthetic. That's why I like to do this, because it ties into synthetic. All right, so if I'm going to synthetically divide this into that, take who you're dividing by, Set it equal to 0. Let's get that magic synthetic number. Guys, technically, it's the A value, your book would call it. I just call it the magic number. Add 1, and x would be 1, okay? Take your 1. Let's get set up for some synthetic. Synthetic allows us to divide in without using the variables. So all I need are my coefficients. But guys, it goes from an x to the 4th, to an x to the 3rd, to an x squared, to a just number. It's missing the x's. So we're going to have to fill in a 0 for the coefficients to our x's in that order. All right, so bring down your coefficients, 3 and 5 and -4. Now 0. 0 would be the next one because the x's should be next, and then 6 should be last. We're waiting for that last number. Once we know that last number, guys, it'll be our remainder, and we can say yes or no. All right, so let's bring down the 3, and we begin that whole multiply, add process. 3 times 1 is 3, and now we add. 5 plus 3 is 8. 8 times 1 is 8, now we add. -4 plus 8 is 4. 4 times 1 is 4. 0 plus 4 is 4. And 4 times 1 is 4. We add, and oh no, 6 plus 4 is 10. Circle the last number. That would be the remainder when you divide this in. So guys, if the remainder is 10, not 0, is that a factor of this polynomial? No, the answer is no. So all you have to do is say no. And sometimes they'll ask you to justify. Well, why is it no? It's no because the remainder was 10, not 0. And that's all you have to say to justify your answer. If something is a factor, it's going to divide evenly in. And this didn't divide evenly in. Okay. So sometimes they'll ask it like this, is it a factor? Or sometimes, guys, they'll just flat out say, what's the remainder? If your job is only needing the remainder, then you just have to do your synthetic and wait for that last number. So I did the next 2 examples for you to save time because I want to use these examples to prove the new shortcut. So guys, if they asked you, is x minus 3 a factor of this polynomial? I don't know, is the remainder 0? So do your synthetic and wait for the last number. Guys, what was the last number? 0. So did it divide evenly in? Yes. So is x minus 3 a factor of that polynomial? The answer would be yes. R equaled 0. Done. All right, what if they asked you the next question? What if they wanted to know, is x plus 2 a factor of that polynomial? Well, does it divide evenly in? I don't know. We got to find it out. So do your synthetic. Wait for the last number. What was the last number? 0. So did it divide evenly in? Yes. The remainder was 0. So the answer to this question would be yes. R equals 0. Okay. So guys, that is how you should be answering these questions right now based off everything you know. Now I'm going to give you a shortcut. This section is on the remainder theorem. The remainder theorem gets you a quicker way to your remainder, where you don't have to do synthetic to figure out who the remainder was. It's even faster, and your calculator does the entire thing for you. So today's lesson is all about what does the remainder theorem tell you to do to get your remainder, okay? So go to the back of your notes and let me show you what the remainder theorem says. It's kind of like magic. So basically what I'm going to do now is I'm just going to give you another option, another way to find out what the remainder would have been, okay? And some of you could be sitting here, well, hey, Hardy, I don't want another way. I'm fine doing synthetic. That's fine. You can continue doing synthetic. But some of you might want to know this shortcut because it really is shorter. Okay, so the fancy schmancy math talk, we got to get past that. But this is the remainder theorem. The remainder theorem says that when you are dividing a polynomial, and they call the polynomial p of x, they kind of write it as a function. Instead of f of x, they're calling it p of x, but it's just the polynomial, okay? If your polynomial is divided by x plus a or x minus a, just like we've been doing with synthetic, then p of a, then basically it says, if you were to find that magic synthetic number still, that magic a value, if you actually plug it in to the polynomial itself, like if you plug it in for x, then the number the polynomial spits out is the remainder. So again, that's probably hard to visualize by reading the definition. I'm going to show you with the example. But basically, the remainder theorem, it's giving you another way to get to your remainder. It is saying to take that magic A value, that magic synthetic number, plug it in, 4x, in the polynomial you're dividing into, and the number that polynomial spits out is the remainder. Now again, it's not saying, hey, everybody pick your favorite number and plug it in, and the number that comes out will be the remainder. No. Only the remainder comes out when you plug that magic A value in, that magic synthetic number. Then it will spit out the remainder, okay? So then the factor theorem kind of goes along with that by saying, if x plus a or x minus a is a factor, then what number will come out of that polynomial when you plug the magic number in? 0. The remainder will be 0. Okay? So again, the remainder theorem is giving you a different way to find the remainder, and the factor theorem is saying that if it's a factor, you better have a remainder of 0. Okay, so guys, this is the exact same example from the front. It's asking the exact same question. Is x minus 1 a factor of that polynomial? And if you guys look on the front, we found out the remainder was 10, so the answer was no. It didn't have a remainder of 0. So now let's do this exact same problem, but instead of getting the remainder by using synthetic, let's get the remainder by what the remainder theorem says, and watch how much quicker you get to your remainder. So the remainder theorem says that take your magic synthetic number A. What is that magic number? So take x minus 1, set it equal to 0, and you get 1. That's your magic synthetic number A. The remainder theorem says instead of setting up synthetic and waiting for that last number, take this magic number 1, plug it in for all the x's. The number that this spits out when you plug 1 in, it's going to be the remainder. So we're going to plug 1 in for x. And the number that comes out represents the remainder. That's what the remainder theorem says. So guys, plug it in. 3 times 1 to the 4th plus 5 times 1 to the 3rd minus 4 times 1 squared, and then plus 6. The number it spits out should be the remainder. And let's see what it is. So guys, plug it into your calculator and hit enter. You don't got to worry about filling missing terms in. You don't got to worry about multiplying or adding wrong. Your calculator will literally do this entire problem for you now. All right, you guys plug it in. I'm going to do it up here during just PEMDAS, and then we'll see what we got. Right? 3 times 1 to the 4th is 3, 5 times 1 to the 3rd is 5, negative 4 times 1 squared is negative 4, and then plus 6. In the order they appear, 3 plus 5 is 8, 8 minus 4 is 4, 4 plus 6 is 10. Guys, look on the front of your notes. What did we circle in that first example as the remainder? It was 10. So this is 10. So the remainder theorem works. The remainder theorem says, if you plug that magic number into the polynomial, the number it spits out will represent the remainder. So guys, the remainder is 10. So what's the answer to this question? Is x minus 1 a factor? Nope. And again, the only thing you'd have to say is the remainder is 10 and not 0. So in the future, if you're answering a question like this, all you need to answer this question is the remainder. You got to know if it divided evenly in. So guys, now you technically have 3 ways to do this problem. You could long divide, get your remainder. You could synthetic divide, get your remainder. Or you could use the remainder theorem. You could plug the number in, and whatever number it spits out, that represents your remainder. And like I said, it's not like any number you plug in, the remainder comes out. It's only that magic synthetic number, when you plug it in, does the remainder come out. All right, so guys, look at example 2. If you look on the front, we found the remainder of this problem was 0. So let's do it using the remainder theorem. Let's see if I get a remainder of 0 by using the remainder theorem. All right, so let's get that magic number. All right, so the remainder theorem says to find the remainder, just plug 3 in. Whatever number it spits out is going to be the remainder. All right, so if you plug 3 in, right, whatever number it spits out, when you plug 3, that magic number in, it'll be the remainder. And what did you get? Think about it. What did we get on the front? What was examples 2's remainder? It was 0. Guys, 3 to the third is 27. 3 squared is 9. 9 times negative 4 is negative 36, and then plus 9. 27 minus 36 is negative 9. Negative 9 plus 9 is 0. What do you get when you plug 3 in? You get 0. So if your remainder is 0, is x minus 3 a factor? Yep. So again, if you're sitting here and you're like, what the hell is this lady talking about? All I'm talking about is that you now have another way to find a remainder. Instead of doing division, you can find a remainder by plugging that magic synthetic number in. That's it. All right, so let's do the last example. Same thing. We already saw, let me move it all the way up. We already saw on the front of our notes, when I filled it in for you, is x plus 2 a factor of that polynomial? On the front of our notes, through synthetic division, we saw the remainder was 0. Prove to me that you still get a remainder of 0 by using the remainder theorem, by plugging that magic number in. All right, so plug it in, and I'm telling you, when you plug that synthetic number in, the number this polynomial spits out, it will represent the remainder. And like I said, we already saw on the front that the remainder was supposed to be 0. So make sure when you plug a negative 2 into this, that it is a 0 coming out. And guys, it is. Negative 8 plus 24 is 16. 16 minus 22 is negative 6. Negative 6 plus 6 is 0. Guys, it is a 0 that you get when you plug negative 2 in. So is it a factor if the remainder was 0? Yeah. The answer is yes. Okay? So, at the end of today, you now know, and guys, I really should have put 3. You now know 3 ways to find the remainder and determine if something is or is not a factor. The first and second way would be long division and synthetic. Long divide, wait for the remainder. Synthetically divide, wait for the remainder. All right, or now you have a third way to find out if something is a factor and find out if the remainder was 0. Now you have the remainder theorem, which says you can plug this synthetic number in and it'll spit out the remainder. Okay, all right. Which again, the remainder theorem just says plug that magic A value, that magic synthetic number in for X, and the remainder will come out. Okay, so tonight's homework, guys, it's really, really easy. It's going to ask you if something is a factor, or it's going to ask you straight out, what is the remainder? You have 3 options. You could long divide, get the answer. You could synthetic divide, get the answer. Or you could just plug it in, use the remainder theorem. Now, I want to show you one of your homework problems. Guys, your homework problems really, really, really want you to use the remainder theorem, and this is why. And let me even show you what they write if you look at their work. Pretty funny. Okay. Let me not show the answer yet. So guys, here's a homework question. This is right out of your homework from tonight. If f of x equals this polynomial, so guys, this is your polynomial. They're calling it f of x, not p of x, but they've just taken a polynomial expression, they've written it as a function. It doesn't matter, all right? If f of x equals this polynomial, then what is the remainder when that polynomial f of x is divided by x minus 2? So guys, they just flat out asked you what's the remainder. They didn't even ask you yes or no, is it a factor? They just want the remainder. So guys, you have three options. Long divide, get the remainder. Synthetic divide, get the remainder. Or use the remainder theorem, which says plug to it. Whatever number comes out of this function, when you plug it to it, it will be the remainder. Because guys, if you're sitting here saying, hey Hardy, I like synthetic, I'm just gonna do synthetic. That's fine, I can't stop you, because look at this problem. If you wanted to do synthetic, right, you'd have your 2, then you get your coefficients, starts with a 4. It's missing an x to the 4th and an x to the 3rd, so you gotta fill in 2 zeros. Then you'd put your 3, it's missing an x term, so you gotta fill in another 0, and then you put your 1. So guys, a lot of the homework problems, they're missing tons of terms. So that's lots of zeros that you have to remember to fill in, and now there's lots of multiplying and adding that you gotta do until you get to that number. So on Delta Math, if you look up how to get the answer, look what they said. If you look up the answer, first they tell you to use the remainder theorem. Plug 2 in, see what number comes out. It's 141. Or they said, or you could do the slow way. They literally call it the slow way because to do synthetic is going to take you so much more time to do all that multiplying, adding, and filling in the zeros, if you even remember to fill in the zeros. All right? So the easiest way to do tonight's homework is to use that remainder theorem. Just plug that number in, let your calculator do all the heavy lifting, and you'll get the remainder that way. But again, there's nothing wrong with doing synthetic. It's just going to take more time. Okay? All right, are you guys okay here? Everybody's all right? Nice and easy, just gotta get remainders. That's all we're getting tonight. All right, at home, are you guys okay? We're just finding remainders, and now you have a new way to find a remainder. Okay, all right, so guys, do you have a homework tonight on Delta Math that looks just like this? It's 10 problems, but guys, it's gonna be quick if you use the remainder theorem, all right? All right, let me take attendance because I didn't do that yet. If I say your name, you'll be good to go. You can start the homework. We have a few minutes left. Otherwise, I'll just see you tomorrow. But if you have any questions, please feel free to hang out and let me know.